Hello children, welcome back to the online teaching sessions of Bharati Vidya Bhavan's Tadepalligudam. I hope you all safe at home. So today I am going to teach you about polynomials. Before going to this topic directly, let us revise the last video concept. In the last video, you have learnt about the definition of an algebraic expression and the types of algebraic expressions. So what is the definition of algebraic expression? It is an expression which contains variables and constants combined by arithmetical operations, and the powers of involved variables must be a rational number. Next, we have discussed about types of algebraic expressions. In that you came to know about monomials, binomials, multinomials, trinomial and polynomials. So in this video we are going to learn about this polynomials. So from the last video itself you came to know that polynomials are the type of algebraic expression, that is polynomial is an algebraic expression. So but when we will call an algebraic expression as a polynomial, that is nothing but what is the definition of a polynomial. So polynomial is an algebraic expression in which the powers of involved variables must be a integer, positive integer. So what is a polynomial? It's an algebraic expression in which the powers of involved variables must be a positive integer. Means if you have taken any expression, if the involved variable's power is rational number, it is an algebraic expression. If the power of involved variables is a positive integer, then only you can call that algebraic expression as polynomials. So to get a clear idea or the better idea about this one, let's take some examples. So here I am going to take some five expressions, and the first expression is x square plus 2, second one x to the power of minus 2 plus 2, and third one x to the power of 1 by 2 plus 2, and the fourth one x square plus 1 by x, and the final one, fifth one, x to the power of root 2 plus 2. So I took 5 expressions. So is these all are algebraic expressions? If they are algebraic expressions, is that expression is a polynomial or not? You took the first expression. Here we are having the variable x. So what is the power of x here? 2. So 2 is a rational number, so it's an algebraic expression, and 2 is also is a positive integer, so it's an algebraic expression and it's a polynomial. Coming to the next one, so x to the power of minus 2 plus 2. Here the variable is x and its power is minus 2. Minus 2 is a rational number, so this expression is a algebraic expression, but minus 2 is not an positive integer, so it's not a polynomial, it's just an algebraic expression. Coming to the third one x to the power of 1 by 2. So here the power of the involved variable is 1 by 2. 1 by 2 is a rational number, but it's not an integer, so this expression x to the power of 1 by 2 plus 2 is an algebraic expression, but it's not a polynomials, it's just an algebraic expression. Next, fourth one, x square plus 1 by x. So here you are containing two terms. In the first term the variable is x and its power is 2. Coming to the second one, it's a positive integer and it's a rational number. Coming to the second term you are having 1 by x. It's nothing but x to the power of minus 1. 1 by x is nothing but x to the power of minus 1. So the power of the variable in the second term is a rational number. So this x square plus 1 by x is an algebraic expression, but the power of in the second term, the variable involved in the second term, its power is negative integer. It's not a positive integer, so it's not a polynomial, but this complete expression x square plus 1 by x is an algebraic expression, but it's not an polynomial. Coming to the last one, fifth expression, if you took means x to the power of, here the variable in the first term is x, the power of the x is root 2. So here root 2 is an irrational number, it's not a rational number. So it's this expression x to the power of 2 plus 2 is not an algebraic expression even. So these are the examples. By these expressions you came to know that what is an algebraic expression and when an algebraic expression is a polynomial. So the condition is, if you want to tell any expression as an algebraic expression, the powers of involved variables must be a rational number or rational numbers. But if you want to tell any algebraic expression as a polynomial, the powers of involved variables among all the terms must be a positive integer. So if you took the fourth expression, it's containing two terms. In the two terms there are variables, but in the first term the variable is having a positive integer, but coming to the second term the power of the variable is a negative integer. That's why this expression is not a polynomial, but it is an algebraic expression. So have you got the clear idea about this definition of polynomials? Yes. Next topic is, what are the different types of polynomials? So here in the last video we came to know that how to find the degree of algebraic expression. Similarly for the polynomials, if you find the degree, so the degree is nothing but the highest power among all the variables involved in the expression. So here, based upon the degree of a polynomials are divided into many types. That if the degree of the polynomial is 1, we will call it as linear polynomial. Means if the degree of the polynomial is 1, we will call it as a linear polynomial. Let's take one example. 2x plus 2. 2x plus 2, the degree of this complete algebraic expression is 1. So, and it is a polynomial. So this type of polynomials we will call as linear polynomial. Next one, quadratic polynomial. Quadratic polynomial means if the polynomial degree is 2, then we will call that polynomial is quadratic polynomial. Let's take an example. X square plus 2x plus 3. So what is the degree of this complete polynomial? 2. So if the degree is 2, we will call it as quadratic polynomial. Next one, cubic polynomial. So if the degree of the polynomial is 3, we will call that polynomial as cubic polynomial. Let's take an example. X cube plus 10. What is the degree of this polynomial? 3. So 3, so it is called a cubic polynomial. If the degree of the polynomial is 4, we will call it as quadric polynomial or biquadric polynomial. That means let's take an expression, x power 4 plus 2x square plus 3. So what is the degree of this complete expression? 4. So this polynomial we will call as a biquadric polynomial or quadric polynomial. So this is about the types of polynomials. Some special cases in this. Let's take one number, like I ask you, like, is it 2 is a polynomial or not? Single number 2 is a polynomial or not? I will say yes. Why? Because you can write 2 as 2 into x to the power of 0. So here anything power 0 is 1. So 2 into 1, it's nothing but 2 into x to the power of 0. So what is the degree of this expression? Is 2 into x to the power of 2x to the power of 0 is an expression. It's an algebraic expression. Why? Because 0 is a rational number. So is it a polynomial? Means yes, obviously. 0 as a positive integer, you can take as positive integer also. So 2x to the power of 0 is a polynomial. That is 2 is a polynomial. So here this which type of polynomial it is? So 2, like numerical numbers like 2, 3, 4, 1 by 2, these all like numerical values we will call as, these are constant polynomials. So 3 is a constant polynomial, 5 is a constant polynomial, 6 is a constant polynomial. So these are all numerical numbers we will call as a constant polynomials. Next one, 0. We will call 0 as a 0 polynomial. 0 is a 0 polynomial. Like numbers like 1, 2, 3, 4, minus 1 by 2, minus 3, these are all called as constant polynomials. These are two special types of polynomials we have. And next, based upon degree, we have discussed the different types of polynomials. Based upon number of terms in the polynomial, we have different types of polynomials also. So if a polynomial contains a single term, we will call it as monomial, just like algebraic expressions only. If a polynomial contains two terms, we will call it as a binomial. If a polynomial contains three terms, we will call it as trinomial. So these are the three types of polynomials. Based upon the terms, we can differentiate. So this is about polynomials and types of polynomials. Thank you.